We're looking at section 5 of our video notes. We're talking about unions and intersections in probability. Unions are where things come together, where either thing can happen or both, whereas intersections are saying only specifically where things overlap. You think of like a intersection of two roads, it's where the two roads very specifically come together. So we're going to look at the words or and in various probability situations. So number 1 here says, using a normal number cube. Whenever we say number cube in math, we're just talking about dice. And whenever we're talking about one dice, it's really called a die. So we're not saying a number cube must die or something like that. We're just rolling dice, except only one of them. So using a normal number cube or a die, find probability of, that's what that P means, probability of 1 or 3 or 5. So if I think of the way dice are laid out, you have a side with a 1, a side with a 2, a side with a 3, and so forth, until you have 4, 5, 6. And 1, 3, 5, that accounts for 3 of the possible 6 options. And on dice, you know that each option has an equal chance of being rolled. So 3 out of 6 should be the probability. Because if I get a 1, or I get a 3, or I get a 5, all of those count as winning or success. So that would be where the 3 comes from in the numerator. The 6 comes from how many possible ways are there to have different outcomes on the single die, and that would be 6 different numbers you could roll. So following that same logic, I'm going to let you try number 2. Number 3, we're going to start using decks of cards. Some of you are very familiar with cards, some of you not as familiar. What you're going to want to do is pull up the chart that is listed on the back of your quiz packet. I'm going to do that right now. You'll see that a standard deck of cards has 52 cards, and those cards come from 13 cards in each of these different suits. You have clubs, diamonds, hearts, and spades. The diamonds and hearts are red, the clubs and spades are black. Now, within each suit you have the ace, which is representing essentially the 1. It takes the place of the 1. You have the numbers 2, 3, 4, 5, 6 all the way to 10. And then you have a jack, queen, and king. Depending on the game you're playing, the ace might be a low number like a 1. It might be a high number like higher than the king. 10, 11, or 11, 12, 13, you can imagine it being like the 14. Or some games allow you to choose what it is. So if you're playing blackjack, you can make the ace worth a high number or a low number. So this layout, this grid allows you to kind of see what we're looking at. So let's go back to an example problem that we're going to see in these situations. It says the probability of black or jack. Now if we go to our chart, 1, 2, all the way up, there's 13 black cards in the clubs and 13 more in the spades. So if I took 13 plus 13, 26 cards already I'm at. And then it says or jack. Well, I have 1, 2, 3, 4, a jack in each different suit. So I would have 4. And you might think, okay, well I'm just going to add that on to the 26 I have, giving me 30. But that's not entirely right, because this jack here, this black jack, and this black jack right here, they were already counted with the black cards. So whenever you're doing or situation, unions, you don't want to double count. There's 2 ways around this. You can just avoid double counting from the start, so I just wouldn't count those 2 jacks, and I would just take the 26 plus this one, plus this one, which would give me 2 more, or 28. Or I could do what I did before, add on the 4, get 30, and then take away the 2 black jacks that got counted twice. So 30 minus 2, 28 gets me back to the same answer either way. Whatever is easier for you. It might be easier even if you take the little chips we have in class and you mark, set that on top of each of the cards just to know that it's marked. and then you can count it up when you're done. So let's write the final answer here. We had 26 plus 2, or 30 minus 2 is 28 out of 52. And we can reduce that the same way we can actually reduce number 1. Number 1 could be reduced to 1/2. This one, if you divide the top and bottom by 4, you would get 7 out of 13. 7 out of 13. Let's skip down to the very next problem, actually number 4. Using a standard deck of cards, find the probability of hearts and black. Now this one is tricky, because if we look at our hearts, the probability that it is a heart and that it is a black card, there are no hearts that are also black cards. So based on that, we would actually say 0. The probability is 0 out of 52, or just plain old 0. Let's do one more with and together, and then the last one will be yours on your own. 2 and black. 2 and black. So if we look at our black cards, we have a bunch of black cards, 26 of them. But it says also it has to be a 2. And the word and means it can't just be either or, it has to be both a black card and a 2. So this 2 of clubs and this 2 of spades are the only 2 cards in the whole deck that meet that requirement. So you would get 2 out of 52 for this one, which reduces to 1 over 26. And I'll leave the last one for you to do on your own.